Have you ever looked at a huge, successful farm and just wondered, how did they even start? It's not as simple as just throwing some seeds in the ground. Nope. It all begins with a blueprint of the land itself. Today, we're going to break down the essentials of farm surveying and planning, all the way from the first measurements to the final product.
So, here's our game plan. We'll kick things off with the what and the why of farm surveying. Then we'll get our hands dirty and look at the actual tools a surveyor uses. After that, we'll see how all that data helps you plan the perfect farmstead. And finally, we'll see how those plans literally turn into plants. Let's dig in.
All right, so first things first, what in the world is farm surveying? Well, you can think of it as creating the ultimate, super detailed, and incredibly accurate map of a farm.
Now, this is way more than just drawing the outline. This is the first, most crucial step to really understanding the land you're working with. A survey captures everything: the size, the exact boundaries, its location on the planet, and, this is a big one, its topography. You know, the unique shape of the land with all its hills, valleys, and slopes. It's like you're creating the ultimate user manual for your property.
Okay, so that sounds like a ton of work, right? Why go through all that trouble? What are the real, actual benefits of measuring every single nook and cranny of a farm? Well, it turns out every single one of those measurements is going to inform a critical decision down the line.
When you look at these points, you can see this is no academic exercise. This has a massive real-world impact. First, it defines your legal boundaries. No arguments with the neighbors. Huge. It also gives you the hard data you need for a feasibility study to see if the farm is even going to work. And of course, it's the key to efficiency, making sure every square foot is used perfectly and that your barns and buildings are exactly where they need to be.
And it goes even deeper. The data helps classify your soil types, which tells you what to plant and what you can expect to harvest. On the business side of things, you want to get a loan? The bank is going to want to see a survey. You want to get your legal certificate of occupation? You need a survey. Plus, understanding the slope of your land is absolutely critical for managing water drainage and stopping soil erosion. A survey is literally the financial, legal, and environmental cornerstone of the entire operation.
All right, so how is all this measuring actually done? Let's crack open the Surveyor's Toolkit and take a look at the cool instruments that make all this precision possible.
Let's start with the tool that looks pretty simple but is absolutely essential: the ranging pole.
Its job is so important. These poles are painted in those bright, alternating colors for one reason, so you can see them from really far away. A surveyor uses them to mark specific points, what they call stations, and to make sure all their measurements are being taken in a perfectly straight line. It's a fundamental tool for keeping everything accurate.
Next up, we've got a classic piece of gear with a ton of history: the Gunter's chain.
This is old-school precision right here. It's a metal chain that's exactly 66 feet long, and because it's made of all these steel links, it doesn't stretch or warp the way a rope might. That makes it incredibly reliable for taking those foundational measurements of length and width across the land.
Okay, from the traditional chain, let's move on to a tool that's probably a bit more familiar to all of us: the measuring tape. Now, unlike the stiff links of a chain, a modern surveyor's tape is flexible, and that flexibility is key. It lets you measure not just straight lines, but also follow the contours of the land and even measure height. It's a super versatile tool for all kinds of detailed measurements.
So, we've covered distance, but a map without direction is kind of useless, right? For that, a surveyor turns to the prismatic compass. This is a brilliant piece of engineering. It lets a surveyor figure out precise directions by taking what are called bearings, which are really just angles relative to north. The prism inside magnifies everything, letting them get super accurate readings of those angles. That's how they map out the exact orientation of a property line.
And now for the real powerhouse of the Surveyor's Toolkit: the theodolite. This is where surveying becomes a true science. A theodolite is a precision instrument for measuring both horizontal and vertical angles with just incredible accuracy. This is the tool you use to fully map out the land's topography. It measures the exact angle of every slope, every hill, every valley, creating a complete three-dimensional picture of the farm.
So, we've used all our tools, we've collected all this incredibly precise data on distance, direction, and elevation. What's next? Well, now we shift from measurement to design. It's time to turn all that data into a plan for the perfect farmstead.
Farm planning is basically that strategic process of using the raw survey data to create a master plan for the whole farm. And the goal is simple, but it's profound: to put every single part of the land to the use for which it is best suited. You're creating a farm that's efficient, productive, and sustainable.
And this process isn't just guesswork. It follows some clear, logical principles. You plant your crops on the most fertile soil, that just makes sense, right? To get the best yield. Livestock buildings, they go on the poorer soil, which saves the good stuff for growing. All your buildings need to be easy to get to, but you don't want them on a steep slope where they could cause erosion. And, for your own sanity, you always separate the noisy, smelly livestock areas from the farm office and the house.
Okay, let's bring this all home. How does all this detailed surveying and planning translate into the day-to-day calculations that you actually need for farming?
It all comes down to some simple but really powerful math. By using those survey measurements, a farmer can use basic geometry to calculate the precise area of any plot of land. And knowing that exact area is absolutely critical for calculating everything: how much seed to buy, how much fertilizer to use, and what your potential harvest will be. Precision in measurement leads directly to precision in farming.
And that really brings us to our final thought. We've seen just how precise measurement and careful planning form this unshakable foundation of a successful farm. So the question I want to leave you with is this: how does this core principle of measuring first and